Good evening and welcome to AMWMB News. Tonight's top story: what is 2 plus 3 plus 5? It's a question that has been rocking our nation to its very core, and so we went to the general public and asked them the question: what is 2 plus 3 plus 5?
Oh, that's obvious, Mr. Balfour. It's 42.
17.
That's easy. That's 1.6 times 10 to the negative 19.
9.
Fascinating. Well, to shed some light on this matter, let's now pass on to our correspondent in the classroom, Mr. B. Hello there. So I think the problem that we're having here is we're talking about resistance. Resistance is the opposition to current flowing in a circuit. For series circuits, to find the total resistance is actually really easy. So here we have a circuit that has got one resistor, and current's flowing through that circuit, and that resistor is opposing the flow of electrons through those wires. An analogy would be over here. So here you have a road network, a motorway, which is like the wire, and then the traffic, the cars and the lorries, would be like the electrons flowing through that wire. Right here we have placed a toll booth. That's somewhere where the traffic has to slow down before they pay and carry on. Effectively, this is opposing the flow of traffic along the motorway. So it's behaving a bit like a resistor. So what happens if you were to add more resistors in series? Well, it would look like this. In the case of the toll booths, what you've done is you've now added 2 more toll booths along the same road. So effectively the traffic is now having to stop at 3 toll booths to pay like a third of their fare before they're able to carry on. Doesn't take a genius to work out that there's going to be more opposition to the flow of traffic, and therefore the flow of traffic is going to be less. So the rule for resistors in series, like I say, is straightforward. The total resistance is just R1 plus R2 plus R3. Every resistor you add increases the total resistance of the circuit. So 2 plus 3 plus 5 is 10 ohms. Congratulations, I have now taught you to add. You have passed primary 3. But it gets a bit more complicated. Because what if we wanted to add resistors in parallel? Well, in this case, the circuit looks like that. Now, you might look at that initially and go, right, we've just added another resistor. So, again, the total resistance should increase, right? Wrong. Look again. There is something much more significant that you have done by adding another resistor in parallel. You have added an entirely new route for the current to flow down. And so actually, the total current that's now able to flow through this circuit has gone up. If you added another branch, that would be another route for the current to flow down, and the current would again increase. Every resistor you add in parallel actually decreases the total resistance. If that doesn't make any sense, let's go back to our traffic analogy. So here we go, we've got 1 toll booth. That would be like having 1 resistor. Okay? If you add resistors in parallel, this is what happens in our analogy. You're adding more toll booths, but you're adding them across the motorway in different lanes. Now, overall, more traffic can flow than could flow when there was just 1 toll booth. you've actually opened up 2 more lanes for the traffic to go through to pay their toll. Every toll booth you add in this way decreases the total resistance and therefore increases the total flow of traffic, or the current. The equation, in this case, is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So if you put the numbers in at this case, you've got 1 over 2 plus 1 over 3 plus 1 over 5. The common denominator to all those is the number 30. So that would be 15 over 30 plus 10 over 30 plus 6 over 30. Just adding fractions up. In total, you would get 31 over 30. Now, if you're not good with fractions, that's fine. You can just put this in your calculator and you'll get that number coming out at the end. So we're all done, yeah? That's final answer, 1.03 ohms. No, because this is 1 over RT. Nobody cares about 1 over RT. Okay? It's like the opinion of a Rangers football fan. Nobody cares. So what do you have to do? You need to get RT, not 1 over RT. And to do that, for a fraction, you flip both of these sides over. This is a crucial step. Don't forget it. And if you've got that out in your calculator, all you would need to do is do 1 divided by that number. In either case, the final answer will be 0.97 ohms. So there you go. In this case, 2 plus 3 plus 5 is actually 0.97. Now, just in case that doesn't actually make enough sense to you, here's a little picture. Lights go out. So if I close the switch here, this is just 1 resistor, and you can see how quickly the electrons are flowing. And in the bottom circuit, I've got 3 resistors. And the total resistance here, right, is 3 times what it is there. So the current is flowing much more slowly. Right? That's like having the 3 toll booths in the same line. Resistance in series, to get the total, you just add them all up. But resistance in parallel is different. Now I've got 3 resistors in parallel. I'm going to close the top switch and look at the current flowing. Okay, the little blue things are representing the electrons. If I close this switch here, remember, I'm now opening up an entirely new route. So the total resistance will get less. Watch the current flow up here. The current should increase. Okay? The resistance is getting less, so the current increases. I could open up a third route, a third branch, and the current will increase again because the resistance is getting less. Okay? The total resistance in a parallel circuit is actually always less than the smallest resistor. I hope that clears things up for you. Back to the studio. Thank you. Well, isn't that remarkable? Who knew 2 plus 3 plus 5 is 10 and 0.97? Tune in next week and we'll be asking the question, which is the prettiest colour? Pale green or sunset orange? The answer may surprise you. Good night.